Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about types of chemical reactions. In this session we are going to see different types of chemical reactions. Okay. First let us see about writing the symbols of physical states of substances in a chemical equation. In the earlier session we have seen what is meant by a balanced chemical equation. If it is not balanced, how to make it balanced equation we have seen. So from the balanced equation, we'll get the quantitative information about the reactants and products of that reaction. And by using the symbols of the physical states of the substances in the chemical reaction, we get some more extra information. By writing these physical states of substances, a chemical equation becomes more informative. For example, if you see this equation, we know this is an equation representing photosynthesis reaction in plants, isn't it? In plants, carbon dioxide and water, these two will combine to form glucose and oxygen gas as products. So here, the gaseous components are represented in a chemical equation by using symbol G in the brackets. If you see the above equation, in this carbon dioxide which is taken by plants is a gas. So to represent this carbon dioxide physical state, in brackets G is used beside the molecular formula of carbon dioxide. So this G represents the physical state of this chemical component as a gas. Okay, in the chemical equations certain chemicals will be in the liquid state. So the liquid state is represented by the symbol L. See here in the same equation, water taken by the plants through their roots in the form of liquid. So water is a liquid. It is represented by using L in the brackets beside the formula of water that represents this chemical component is a liquid substance. And certain solid substances present in a chemical equation are represented by using the symbol S. Solid state is written by symbol S. See here in the same equation glucose. Glucose as a product it is in the solid state. So its state is represented by using S beside the formula of that compound. Okay, in this way the physical states of the substances we can represent by using certain symbols. This physical state representation gives some more additional information about the chemical reaction. And even not only these solids, liquids and gases, there is one more representation, that is aqueous component representation. Aqueous solution is written by the symbol AQ. That means certain solid substances they cannot directly react or they cannot directly participate in the chemical reaction. That is why they will be taken in the dissolution position, dissolved position. When a substance dissolved into the water, that forms a solution. That solution formed is called aqueous solution. For example, if you take sodium chloride cannot react directly in many chemical reactions. That is why it will be taken in the aqueous form. Means sodium chloride will be dissolved into the water and it forms a sodium chloride solution. Thus the formed solution is called aqueous sodium chloride solution. Aqua represents water. Aqueous solution means in that solution the solvent is water. So such kind of substances, if they participate in the chemical reaction, their physical state is mentioned by using the symbol AQ in the brackets beside its molecular formula. Okay, in this way the physical states of these substances are represented by using these symbols. Okay, writing the condition in which reaction takes place. This is one more information about the chemical reaction. The condition is generally written above or below the arrow mark in the chemical equation. We know the arrow mark is in between the chemical reactants and products. Arrow mark separates the reactants and products in the chemical equation. On this arrow mark, the conditions needed for that reaction generally represented. Thus, by writing the symbols of the physical states of the substances and the conditions under which reaction taking place, by writing these all, a chemical equation can be made more informative. Not just by using symbols and formula of the components participating, by using the physical state symbols and the conditions necessary for the reaction. If these all are represented in the chemical equation, then that equation will be more informative. For example, if you see the reaction between nitrogen and hydrogen in the formation of ammonia, the complete information is given by using this equation. See here, just if I write N2 plus 3H2 gives 2NH3, it gives information about the chemical substances participating and the substances being formed only. If you use the physical states of those components and the conditions required for that reaction, then that chemical equation gives more information. It becomes more informative. See the same ammonia gas. So ammonia gas is formed by the reaction of nitrogen gas and hydrogen gas at very high temperature, around at 450 degrees Celsius temperature. This is happening in the presence of a catalyst iron, which is also called here as molybdenated iron, or in details to say iron is acting as here catalyst and molybdenum is acting as promoter in this reaction. Of course, no worry, we are going to study about this in detail in further classes. So here iron and molybdenum together considered as molybdenized iron. This is acting as catalyst in this reaction. We know what is meant by catalyst already. Catalyst means the chemical substance which speeds up the reaction without participating in the chemical reaction. So in this reaction, nitrogen and hydrogen only participating. But this iron or molybdenized iron is used as catalyst which speeds up the reaction without participating in it. It will remain as it is after the reaction also. So these are the additional informations given in a chemical equation. The physical states are understood and under which conditions this reaction is taking place is understood by writing these information on the arrow mark. Okay. Now let us see different types of chemical reactions. Here let us see some important types of chemical reactions. They are combination reactions, decomposition reactions, displacement reactions, and double displacement reactions. Let us say about these one by one. First among those is combination reactions. The chemical reactions in which two or more substances combine to form is sorry, a single substance are called combination reactions. Okay, the chemical reactions in which two or more substances combine together to form a single substance are called combination reactions. So in a combination reaction, two or more elements they may combine to form a single compound, or two or more compounds they may combine to form a new compound, and even in certain chemical reactions an element and a compound also can combine to form a new compound. So with the different combinations, these combination reactions may occur. So in this way, two or more substances combine together to form a new substance. In these reactions, these are called combination reactions. So here A and B might be two elements or two compounds or one compound and one element. The combination might be between any. Let us see these one by one examples. Hydrogen burns an oxygen to form water. We know hydrogen reacts with the oxygen to form water. In this reaction, hydrogen and oxygen, two elements are participating. They are combining together to form a new compound, water. So this is one combination reaction in which two elements are combined together to form a compound. Okay, this is a combination between two elements. Let us see one more example which describes the combination of two compounds. Ammonia reacts with hydrogen chloride to form ammonium chloride. So here ammonia reacting with hydrogen chloride to form ammonium chloride. So here two substances combine together to form a new compound. This is a combination reaction. In this combination reaction, two compounds are combining, isn't it? Ammonia is a compound, hydrogen chloride is also a compound. So two compounds are combining together to form a new substance. So it is a combination reaction between two compounds. Okay, so it is also a combination reaction. Let us see another kind. Carbon monoxide reacts with oxygen to form carbon dioxide. So what's happening in this reaction? In this reaction, carbon monoxide, which is a compound, it is combining or reacting with oxygen, which is an element, and forming carbon dioxide, a new compound. So here two substances are combining to form a new substance. So it is a combination reaction. And in this combination, a compound and an element are combining. Okay, compound and element are combining to form a new compound. So it is a combination reaction. So in this way, combination of two or more elements or compounds or elements and compounds may result in the formation of a new substance. These all reactions are called as combination reactions. Okay, so it is also a combination reaction. Now let us see another kind of reaction, that is a decomposition reaction. The chemical reactions in which a compound splits into two or more simpler substances are known as decomposition reaction. For example, see symbolic representation of equation. AB is a compound. It is splitting into A and B two new substances. Means a single substance splitting into two substances. This kind of reactions are called decomposition reactions. So the decomposition reactions are also of different kinds based upon the conditions. The decomposition reactions are carried out by applying heat energy, and some decompositions are carried out by applying light energy, and some other are by applying electricity. In this way, different decomposition reactions may be there. Let us see about these also in detail. For example, when calcium carbonate is heated, it decomposes to give calcium oxide and carbon dioxide. Okay, here calcium carbonate is decomposed by heating into two simpler substances. So when a decomposition reaction is carried out by heating, that reaction is said to be thermal decomposition reaction. So here calcium carbonate is decomposed into two simpler substances, calcium oxide and carbon dioxide. This is happened by heating. Thus, this reaction is said to be thermal decomposition reaction. So in this reaction, one substance, that is calcium carbonate, is breaking up into two simpler substances. They are calcium oxide and carbon dioxide. So this is decomposition and it is done by heating. So it is called thermal decomposition. Okay, let us see one more decomposition. Some decomposition reactions, they are carried out by using electricity also. For example, when electric current is passed through acidified water, it decomposes to give hydrogen and oxygen gases. We know this is called electrolysis of water. Electro means by using electricity. Lysis means splitting. Electrolysis of water means splitting of water into hydrogen and oxygen by using electricity. Okay, as we know, pure water is a bad conductor of electricity. For water, a small quantity of acid will be added. The water with a small quantity of acid is called acidified water. So by applying electric current into this, the water molecules split into hydrogen and oxygen. Two new elements are formed. Okay, a compound splits into two simpler substances. Hence, it is decomposition reaction, and it is carried out by applying electricity. Okay, this decomposition reaction takes place by the action of electricity. So, these reactions, which are in which compounds are splitting into simpler substances by applying electricity, are called electrolysis reactions. So here we have seen decomposition of water into hydrogen and oxygen by applying electricity. So this reaction is called electrolysis of water, means splitting of water by applying electricity. Okay, this is one kind of decomposition reaction. And some decomposition reactions are carried out by light energy also. For example, when silver chloride is exposed to light, it decomposes to silver metal and chlorine gas. So what's happening here? A compound splitting into two simpler substances. So it is a decomposition reaction. And this decomposition is occurring in the presence of light energy. Okay, these are called photothermal reactions. Means photo means light energy. So with the help of light energy, this decomposition reaction is occurring. That is why this is called photo decomposition reaction. Okay, photolysis it is called. So here a compound splitting into two simpler substances. So it is a decomposition reaction which is carried out by the help of light energy. So in this way, decomposition may occur with the help of heat energy, with the help of electrical energy, and even with the light energy also. Okay. Now let us see another kind of chemical reactions, that is displacement reactions. So the chemical reactions in which one element takes the place of another element in a compound are known as displacement reactions. So in these reactions, one element replaces another element replaces another element from a compound and forms a new substance. Such kind of reactions are called displacement reactions. See here, when an example is given, AB is a chemical compound. It is combining with an element C. Now, here C replacing A and forming a new compound BC. So, here C replacing A. Such kind of reactions in which one element replaces another element from a compound are called as chemical displacement reactions. Generally, a more reactive element displaces a less reactive element from its compound. See here, from this we can understand here, C is more reactive than A. That is why C replacing A from its compound and forming a new compound here. Okay, this kind of reactions are called displacement reactions. Generally, more reactive elements displaces less reactive elements from their compounds, and thus they form new compounds here. Let us see an example for this. When a strip of zinc metal is placed in copper sulfate solution, then zinc sulfate solution and copper are obtained. See here, this blue colored solution is a copper sulfate solution. Copper sulfate is in the blue color. If a small piece of zinc is dropped into the solution, here zinc is being more reactive than copper. It displaces copper from copper sulfate and it forms zinc sulfate, which is colorless. So after certain time, after dipping this zinc piece into copper sulfate solution, we observe the blue colored solution turns into colorless solution. This is because zinc displacing copper from copper sulfate on forming zinc sulfate. So this zinc sulfate is being colorless, the solution turns into colorless solution, colorless liquid. Okay, this kind of reactions in which more reactive element displacing less reactive element from its compound to form a new substance is called displacement reaction. Okay, in this reaction, zinc displaces copper from copper sulfate so that copper is being free. So here copper will be deposited down. This displacement reaction takes place because zinc is being more reactive than copper. Okay. Now let us see another kind of chemical reactions, that is double displacement reactions. The chemical reactions in which two compounds react by an exchange of their ions to form two new compounds are called as double displacement reactions. What we can say, the chemical reactions in which two compounds exchange their ions mutually to form two new compounds are called double displacement reactions, or double decomposition reactions are also there called. For example, see this symbolic representation of this. AB is a compound, CD is another compound. If these two are combining, they are exchanging their radicals. Here, the radical D is coming and combining with A, and this B is coming and combining with C, and thus they are forming two new compounds. So what's happening here? They are exchanging their ions mutually to form new substances. This kind of reactions are called double displacement or double decomposition reactions, because two compounds, they are splitting into simpler substances and they are rejoining their ions to form new compounds. That's why they are called double decomposition or double displacement reactions. Let us see an example for this. When barium chloride solution is added to sodium sulfate solution, then a white precipitate of barium sulfate is formed along with the sodium chloride. See here, barium chloride a compound, sodium sulfate is another compound. When these two are combining, they are exchanging their radicals mutually, their ions mutually. This chlorine comes and combines with sodium and forms sodium chloride. And here the sulfate ion comes and combines with barium, forming barium sulfate. So two new substances are formed. Here the formation of new substances can be identified by the formation of white precipitate of barium sulfate. Okay, in this reaction, two compounds barium chloride and sodium sulfate react to form new compounds barium sulfate and sodium chloride. So here these two new compounds are formed by the mutual exchange of their ions. Hence this reaction is called double displacement reaction. So in this reaction, barium sulfate is formed as a white precipitate. So the white insoluble solid substance here formed is called white precipitate, which separates out suddenly from the solution. Actually, barium chloride and sodium sulfate are aqueous substances. They dissolve into water and they form colorless solutions. But when these two are mixed, immediately they form barium sulfate, which is insoluble substance into the water. Hence, it will be appear like a white precipitate and settles down. So by the formation of this white turbidity or precipitate, we can understand as reaction occurred between those two by the mutual exchange of ions. Okay, so here we have to understand one point. Any reaction in which an insoluble solid substance called precipitate is formed that separates from the solution is called a precipitation reaction. So here we can say barium chloride sodium sulfate reaction is said to be double displacement reaction, and in this barium sulfate is formed as a precipitate, and hence we can say this reaction also as precipitation reaction, because a white precipitate of barium sulfate is formed in this reaction. Okay, this double displacement reaction here is a precipitation reaction. Okay, these are the different types of chemical reactions. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.